Thank you, Stefan. Good morning. And yes, so this one, so I'm going to sit because it's very convenient, right? So this presentation is usually what I'm doing during the BayesiaLab conference is presenting the new features. But here today, this is not my choice. I wanted just to stop a little bit and see what we do with all these graphs, right? And to recap all the different types of graph we have, what are the methodologies, and so on, right? Instead of just, so obviously I will present some new things, but it's really like just to see all the workflows, right? So the title is Graph Intelligence for Explainable Decision Making. So this is very important, this explainable thing. So this is because everything is based on graphs, so we can clearly understand what is behind the model, right? And so, well, I chose this one for introducing myself, but I think it's okay for everybody. And I'm going to use my usual introduction here to present the workflow, right? So we are dedicated to Bayesian networks since almost 30 years. And so this is a directed acyclic graph, right? So this is the brain, if you will, of our expert system. Right? And so here it's just a short video that I'm used to present when I don't have lots of time, right? So just to explain what is a Bayesian network. So this is here a Bayesian network that is quite special because it's, you know, the nodes are coming from data. So this is coming from the US soldiers, right? And so we have a small data set with some data about US soldiers. And obviously we can do machine learning with that. So the nodes are coming from the data set, but here, so the point is that the relationship that you see are being automatically created by using HellixMap, right? So I did not do any structural learning. First glitch. But I use HellixMap for finding what are the causal relationships. So remember, when we do machine learning, there is no way to know if this is gender height or height gender. There is a correlation, but we don't know if it's causal or not. So we need to ask an expert to know if it's really height that is a cause of gender or gender cause of height, right? So now that we have HellixMap, we always have at our disposal an expert for finding the causal orientations, right? So here you have the links, so they are blue and red. Blue because this is a positive effect, red it's a negative effect, and you have a comment also that has been associated with the link. So not only you have a causal network, but you have also explanation with this, right? So then if I, oops, this is not what I meant to do. Come on. Okay. This is a glitch for me now. Doesn't want to start. Okay, so I'm going to do that this way. So even though I use...
JC, you sound very silent, so let's...
Okay. So even though I use HellixMap for finding the relationship, the parameters have been estimated by using the data, right? So the qualitative part of the Bayesian network comes from HellixMap, but the estimation of the parameters is directly done via the data, right? So we have these 2 states for gender, 3 states for height, so it's a continuous variable. So obviously we had to discretize it. So this is a way to see the distribution of the continuous values. We had to discretize it. So here it's just based on R squared genopt, right? And then, so obviously we use the data for estimating the conditional probability distribution. So what is the probability of being of measuring more than 178 centimeters? So given that you are a man or a woman, so this is coming from the data, right? And we can also see that you have images associated with the nodes, and this is also coming from HellixMap. So you can use HellixMap for generating images like that to illustrate your graph, right? And then, so this is the qualitative part. And obviously, you can use it for inference. So if I switch to validation, then I can use my scenarios, you remember that. So we have here, I have saved scenarios, and then I can play with that. So here I'm just setting the first evidence that I have saved in my scenario file. So the first scenario is I'm focusing on man, right? So I have a US soldier that is a man, and then I can see that the information is propagated. So given that this is a man, the probability that he measures more than 178 centimeters is 41%, right? And then this is also propagated on the BMI. This is propagated on the weight, but you see age is not impacted because it's de-separated from gender, right? Then if I continue and go to my second evidence automatically with my evidence scenario file here, now I'm setting, so the first type of evidence I use here, it was like simulation from the causes to the effect. Now I'm doing a kind of diagnosis. So I'm setting evidence on BMI. So even though Dave said it's useless now. So here I'm focusing on US soldiers that have a low BMI, and we can see this is back propagating and updating the probability that at the end of the day, we have almost 78% of chance that this is a woman, right? So you see with the blue arcs. And then I continue, and if I set evidence on, so I know that the BMI is low, and I know that this is a young soldier between 18 and 28. So these two pieces of information are used for updating all the probabilities, right? So this is at the same time simulation and diagnosis. So this is really the power of Bayesian networks. You have a model of your domain, and then you can set pieces of evidence everywhere to update the probability of all the nodes for which you don't have any evidence. All right? So this is really just a way to introduce Bayesian network to those who are not familiar with that. So you are, but I think it's nice to see these new types of Bayesian networks where you have a mix between machine learning and also HellixMap, right? So this really, so we are building these networks for creating the brain of our expert knowledge, right? Of expert system, sorry. And we have indeed 3 ways to create these networks. So when we created Bayesian in 2001, we were the first commercial company to provide machine learning algorithm, right? So we created Bayesian exactly for that, because all the other software were just based on knowledge modeling, right? So we had a large set of machine learning algorithms. So this is the first way to create automatically a Bayesian network. So you have data, and you use machine learning for creating the network. Then, obviously, we can also create that manually. So this is what we call knowledge modeling, by using expert knowledge. And since 2 or 3 years now, we can do knowledge mining, which means that we are using LLMs and we are extracting, the knowledge that is encoded, if you want, in the deep neural network of the LLM for creating white boxes, something that is explainable, right? And then once we have the network, so these 3 sources of information are not exclusive. So you can do machine learning and use expert knowledge for biasing your machine learning, or you can start by doing expert knowledge and then use machine learning for improving your network. You can use the LLM at the same time. So this is really 3 sources of information that you can use for that. And then once you have your network, you can do decision support for simulation, diagnosis. So this is what I've shown you with the US Army example. You can analyze, obviously, your domain. You can do optimization. And since we are working with probabilities, obviously, you can do risk management, right? And so here I wanted also to highlight, because now it's not just BayesiaLab, the ecosystem is increasing. So we have obviously BayesiaLab, where this is the tool that allows you to create this graph. We have also the WebSimulator. So this is for sharing your model with your peers, where those who don't have any license, but they can still use your network that you have designed for trying to solve problems. You have Biki. So Biki, this is our tool for brainstorming sessions. So when we do knowledge modeling, but with a group of experts, right? So this is a web platform that allows us to reduce all the cognitive, no, not all, but reduce a large set of cognitive biases. So based on the Delphi approach. And we have obviously HellixMap for the knowledge mining, right? So we have these four pieces of software. And since it was not enough, we created a new one, a fifth one, HellixMap. So this one is really for the other way to use Bayesian networks is for knowledge interpretation, where so you can use it for visualization, you can use it for exploration, to explore your network, specifically when they are big, and for sharing your network. So the web simulators allows you to share your model for allowing your peers to do inference. HellixMap will allow you to share the structure, right? And then they are going to be able to explore the graph, okay? And we are really dedicated to knowledge modeling, right? So even we are building Bayesian network for representing the domain, and but sometimes there are other type of graphs that can be useful for that too. So we are now also not really learning, but extracting knowledge graphs, so which are not acyclic by definition. We have also, so this is our semantic here, our names if you want. So what we call the causal semantic diagrams, we have semantic flowcharts, we have semantic networks. So we have all these different types of graph now that we can also create. And they are always for trying to understand the domain. So because I was doing lots of brainstorming sessions during the last few years, and so in very large set of problems that I was not a specialist of. So it was very nice to have this kind of tool for understanding the domain. When you work with the European Commission for modeling poverty in the world, or when you then the day after that you are working for a company that is just digging or building roads, and then after that you are optimizing formulas for L'Oreal. So lots of different topics. So thanks to this knowledge graph and causal semantic diagram and so on, it's very easy to get an idea of the domain that you are dealing with, right? So these are, again, not Bayesian network, but allows you to create Bayesian networks, right? And this is, so you can create these different types of graph within BayesiaLab, but this is also something that you can do now with HellixMap, because we have integrated the HellixMap API within HellixMap, right? So HellixMap is not just for sharing sharing graph, but also for generating them, right? So let's take the first example. So when you are alone and you create your network, so this is what we call knowledge modeling. So this is what Pearl did in the 80s. So you had to be a specialist of your domain and also a specialist of Bayesian network to create your graph, right? So this is an example here. With COVID, we had lots of graph like that. So just to illustrate, you are alone, you are a specialist of your domain. And here it's a very simple network where you want to see what is the probability of having COVID, given that you have a positive or negative PCR test. And here I have integrated specificity and sensitivity directly in my network. So this is really by creating nodes manually, setting the values. And here, so I have a prevalence of 0.1. And in the PCR test, the conditional probability table, in order to be able to play with specificity and sensitivity, I have created this formula where, so COVID, it's going to be true when you have COVID and sensitivity is true, or when you don't have COVID and the specificity is false, right? So thanks to that, you are taking into account both specificity and sensitivity. And then I go there to the WebSim. So if I want to share this model, I can just create a web simulator. So it takes just a few minutes for that. And if I want, I can change here the prevalence. So I'm going to set 0.05%. and I'm going to say that my swap test is positive. So I see 4% of chance, even though I have a swap test positive, I just have 5% of chance to have COVID, right? And if I decrease the sensitivity, it's decreasing. If I say, okay, now the prevalence is 1%, so you see it's 45%. So you can play with that and decrease here the specificity and so on. So you can really share your model and allow people to play with your network. Right? You can also, when you create your network manually, you can also create dynamic Bayesian networks, right? So take into account the temporal dimension. So this is a network that I've created more than 20 years ago. It was an academic research for representing, this system of distribution of fluids. And so you see when it's, I'm going to go here. Sure. So this is this system where here I'm taking into account that the valves are gonna, there is a risk that they are gonna switch states, over time. So here I'm just saying that this is a state of valve 1 at time step t minus 1, and this is time step t, and here we just describe the priority. So if the valve is okay, so at t plus 1, which can be plus 1, can be an hour or 1 day or whatever. So the priority is that it's going to be, it will stick open is 0.2 and stick close 0.1. And if it's stick open already, then it will remain in that state. It will not repair automatically. The same thing for stick close, right? So we have this dynamic representation for the 3 valves, and here we have the logic that represent, that represents this system here. So if this one stick close, obviously you will not have any fluid, right? And then once you have that, you switch to validation. So this is time step 0, and I can use here this tool for simulating time. So let's suppose I want to see what happened in 2000 time steps. So I just simulate that, and I can just have a look at the evolution of the probabilities over time, right? And then I see that after 2000 time step, if I don't do anything, my system will be in failure, okay? And so you have the evolution of the probability of all the valves here, right? Then you can also, so we have seen basic Bayesian networks, we have seen dynamic Bayesian network, and we can also design inference diagrams, right? So these are Bayesian networks where you have on top of them utility nodes and decision nodes, right? So this is a very simple one where the Bayesian network at the end of the day is just made of 2 nodes here. And then you have 2 decision nodes, seismic test and real, and 2 utilities, the cost for doing the test and the gain. So if you drill and if you have oil, then you're going to be rich. Otherwise, you're going to lose money. And then with this modeling here, we can again go there. You can optimize. So you just go to optimization, learn static policy here, and it will estimate for you the value. So here, if you do the test, you are gonna, on average, win or earn 20.5, 22.5, right? And then if you don't, and if you still behave optimally, you will earn only 20. So it's better to invest in the test. And then you have here for the drill action, here when it's blue, this means this is the optimal decision that is suggested. So here you always have to drill except if the test is negative, right? So it's a very simple inference diagram, but just to illustrate that another type of graph, right? So now let's switch to knowledge modeling, but when you are not alone, right? So we do that a lot now. We are working with group of experts. So this is very nice because you are extracting the knowledge of the experts. So this is, company are really looking for this kind of solution. So as you can see, I've used here DALI for generating this nice picture. And just for fun, I'm going to show you the other one I had before. I had this one, but it was like an AA meeting for illustrating. So I say, no, this is not good. And then I tried another one. I say, I want something more technical, but then I have this helmet that is working alone. So this is a good example of what we do when we generate graphs too, because here you see it's clearly hallucination, but this is obvious. But when we create graphs, we can have this kind of thing, but it's not that easy to identify, right? And you see they are looking in direction. It's very strange. Anyway, so here, this is a model that we have created by brainstorming. And it was just, perhaps I already showed you this graph before, but this is something I've done with L'Oréal, because we had lots of brainstorming projects and they had a problem, too many brainstorming projects. So we had to find a way to do some kind of triage. And then we did a brainstorming session in order to know when to do brainstorming, right? So it's a meta model, if you want. So they paid me for that. I was super happy because it was the first time I was also an expert, because usually I'm the facilitator, but not the expert. And to be honest, when I was in the train going to Paris, I said, I don't know what I'm going to say, because I have my 3-4 slides on Biki, but on top of that, it's going to be over. But it's a very impressive approach, because you are really brainstorming and finding nodes just by discussing with the other experts, right? So this is a graph we came up with. And so it's a very nice tool, because it's also a very nice model for explaining what is a brainstorming session and what you have to do in order to have a successful brainstorming session. So if you want, I can just go there, and there is a simulator for that. So obviously, so it's not just a simulator, it's here an adaptive questionnaire. So you have on the right the targets. We have 2 targets here. So the condition of the project and the quality of the model. And here you have the best question to ask in order to reduce the uncertainty on these targets, right? So here, obviously, like all brainstorming project, the key question is that you need to have a clearly defined question. If the question is not well defined, it's going to be a failure, right? And so let's suppose we have a clearly defined question. Then the second most important driver is that the experts have identified, or they know what they are going to have at the very end of the session. Because I've done lots of brainstorming sessions with dermatologists, and after the session, so we have the model, and then we start to play with the simulator. And they were surprised. They said, "Oh, we did that." So they were really surprised to achieve this kind of result. So it's very nice it's very important to show them what they're going to have at the very end of the day, right? And then so you can really play with that. So let's suppose you have anticipated. Then you need to have a BBN modeler with experience. This allows you to define the size of the group, because you need to have redundancy, but you don't want to have too many experts, because otherwise you're going to lose time, and so on and so forth. So very useful for helping to decide if you can implement a brainstorming session in your company or not, right? Then, so we have seen knowledge modeling with Bayesian networks, inference diagram, dynamic Bayesian network, brainstorming. So now we switch to the machine learning. We have structured data, and then we can do unsupervised learning. So this means that we have the data that is supposed to sample the domain, and we want just to create a graph that is a compact representation of this domain, right? So here we have this example with COVID again. Then we can do supervised learning. So this is when we have a target node. So this is again a medical example here that I've done with a Belgium team. And here, so this is by using data dedicated to identifying the critical illness here. And then, so you can, same thing, share this model and say, what is the prior mean? Well, the severity classification, acute kidney injury, and so on and so forth, and compute here the critical illness, right? We can do variable clustering, right? So this is trying to identify. So what I was quite surprised yesterday that they were using, so not enough words for that. So we have factor, we have clusters, and they came up with communities. So was okay. So what next? so this is what we call factors, right? And so here for that, we first do unsupervised learning to identify the connection between the nodes, and then by using the Kullback-Leibler divergence, we are creating groups of nodes, right? And at the end of the day, we have these nice clusters. And so the thing now is that these clusters can be automatically named. So by Hellixia, we'll give you a name for each group of nodes. So this is very, very efficient. And so we can also do data clustering. So variable clustering, this is, we are clustering the columns, if you want, and data clustering, we are clustering the rows. And here it's an example of a hierarchical data clustering, because I first did variable clustering, and then for each cluster of variable, I created a latent variable by using data clustering. And then I did data clustering of my data clusters, right? So this is what you have here. And as you can see, it was also tedious before, because when you do data clustering, you need to interpret what are C1, C2, C3, C4, C5. So now we have also a way to use Hellixia for directly finding the best name for each cluster, right? So before it was like, yes, perhaps in half an hour you need to interact, to do inference in order to know what are the different clusters. So now it's directly done, right? And then the last one, the kind of Formula One, is what we call the probabilistic structural equation models. And this one, so it's more or less the same thing as what I've done with the hierarchical data clustering, but it's not, we don't create a cluster, we set the target node here that will be explained by the factors, right? And here it's a very specific example, so it's for market research. So where you have it on the left side, you have the part that is dedicated to represent the consumer effects, right? Or the consumer part. And on the right side, you have the experts. So the specialists who have evaluated the product, right? So these are two different data sets. So you have perhaps 5,000 samples on the left and perhaps 70 on the right. And so it's a challenge to make the connection between these two. So we do that by just using the product. And this allows us to optimize the product by using directly the technical information that comes from the sensorial experts and having a bridge to the consumer part, right? So this was a PSEM. And then we go to the knowledge mining, so the third source of information. And here I'm starting with the automatic semantic network generator. So we already talked about that yesterday, but it's based on keywords. So you see, Stephen, you have now 169. So 169 keywords that I have selected. And here I'm interested in, my question is, what is generative engine optimization, right? So this is my topic, and for that, I know that choosing the keyword is not easy, so I have created predefined set of keywords. So here I've selected the ones that I've named the domain description, that is based on 10 keywords. So for example, you have aspect is one of these keywords, right? So I'm gonna use Hellixia for finding what are the most important dimensions. For example, what are the most important aspects that are associated with generative engine optimization, right? And then I will end up with that. So here you see a semantic network. So you have one node. I think you cannot read that, obviously. Each color represents one keyword, and it has been machine learned. So here it's a workflow. So we first use Hellixia for finding what are the nodes that correspond to our keywords. Then we generate embeddings, and then we have a data set. And then on top of that, we use a maximum weight spanning tree for finding the relationship between the nodes that we have extracted with Hellixia. And then this is the reason why we call semantic network. We're going to have connection between the nodes that are closely related from a semantic point of view. Right? And then when I do this kind of semantic networks, the first thing to do is to switch to the node force analysis. So this way, I think it's easier to understand. So the size of the bubble here represents the force of the node, but in that case, since we are using embeddings, at the end of the day, it's just proportional to the number of connection of the nodes, right? And then so you have here all the dimensions that are important in the GEO here, right? So I'm not going to spend time on this. Then what I done after that, so I have my nodes that comes from the keywords, and I use Hellixia for finding the causal relationship between these nodes. So here you see I call that implicit causal relationship finder because I'm using the knowledge that is encoded in the LLM, right? So this is what I call the implicit knowledge of these LLM, right? So by using Hellixia, we can identify what are the causal relationship between the nodes that are being generated by the keywords. And then here we are going to switch now because you see a graph like that, not that easy to understand. So I'm going to go to HellixMap. And so this is, you can directly from BayesiaLab, you go to tools and you have published to HellixMap, and then you will directly have this in this tool. And you have, so I'm not going to go explain this too much, but you can choose different types of nodes. So are you going to use disk or badges with comments, right? Then, so let me go back to simple badge. The arts, you can also have labels like that or directly a badge with a label. And so I'm going to hide them for the moment. And then you have lots of layout algorithms that are available. And I'm going to use here ELK vertical layout. Just do run to get this. And after that, I can also hide this. And so it's a URL. So you have the QR code. So if you scan the QR code, you are going to be able to have access to this model. And then I can quickly, with the mouse, you can zoom in, zoom out. And then you can also, if you double click on a node, you will have the neighborhood of the node, right? And I don't know if you see that, but we have also these new icons that have been associated with the nodes, just to let you know if you are missing something. So because I was navigating a lot of, for example, here, I have optimized content corpus that is linked to comprehensive about. So you have this explanation, what is explanation of this link? And then I was losing time double clicking on this one to try to find information, but at the end of the day, there is no information, no additional information. So here, what I know that this node has one hidden parent and 4 hidden children, right? So if I do that, I have the hidden parents and the other 4 here. So this helps you navigate in the graph, right? And if I double click on the background, I will go back to the original graph. And if you display this, you can also select classes. So you can go to select the different classes that you want to highlight. You can navigate between the classes and so on and so forth, right? Then we can also create a knowledge graph, right? So here the idea is just to say, I'm interested in GEO, give me the knowledge graph that represents this domain. And so a knowledge graph, you have entities and you have, a connection between these entities that can be, taxonomics, that can be partitive, that can be temporal, that can be causal. So you have lots of different types of relationships. So here you see GEO evolves from the SEO, right? Enhance digital visibility, will implement content optimization. So this graph, so are qualitative graphs. So there is no parameters, right? So this is just a way to have a knowledge of this. Are you familiar with GEO? No, because this is the new way, because now Google is going to be out of business in a few, except if they use that too. But now you are not using Google for finding things. You use ChatGPT or any other tool. You say, well, I want to purchase a luggage with this and this characteristics, and then you're going to have a carousel with the links to the shop, the store, and so on. And then now the brands are just worried. They want to be in the carousel. So And it's not just optimization of the keywords now. So you need to have to take into account lots of new things. So to understand how the LLM are working, what are the prompts of the users, and so on and so forth. So this is a new area of research. And so this is the knowledge graph, that a very simple one that represents this domain. We can also generate what we call semantic flowcharts, right? So this is something where it's more or less like, yes, this is a story, if you want. So it's like a knowledge graph, but where we are just focusing on the temporal relationship, right? So this, I designed this semantic flowchart at the very beginning because I'm using that for analyzing books, philosophical stuff, and so on. So when you do that on a book, you're going to have the story, more or less, as it is organized. If you do that on an article, you're going to have the abstract, and so on and so forth. So here you have a representation. So what is a flowchart of a GEO? And if we go there, hide this. So you see, this is, we have the traditional SEO that precedes the emergence of large language models, and then we shift here, we have the GEO optimization, then we have all these components, and then so this is really the sequence between the entities of the domains, right? Then we have causal semantic diagrams. So same thing, very close to knowledge graph, but now we are just focusing on causal relationship. So, right? So knowledge graph, you have any types, any kind of relationship between the entities. Semantic flowcharts, it's like a knowledge graph, but where we just focus on temporal relationship. And here we are just focusing on causal relationships, right? And so here we see the same thing here. We go from the traditional SEO to GEO and so on and so forth. So perhaps I'm going to skip this part because I don't know what time is it. Do I have time? Yeah. No, so this is how you can share this kind of knowledge, right? So when you hover over a link, you have the definition, and perhaps here I can go there this way. This guy, the comments are not too long, so you can do that. So it's quite convenient to have the labels on the link too, or just do this way. Okay, so you can move that too. Then we have the causal network. So causal semantic diagram. Again, it's like a knowledge graph with causal relationship. So it's not a Bayesian network. Well, it can be, but there is no parameters, if you want. Here it's a causal network, so it's really a Bayesian network with parameters. And so we have the target that is here, the GEO, and so it's a constraint network, right? So when you use the causal relationship finder, there is no constraint. We create a causal network. We find a causal relationship between the nodes. But with the causal network tool, we are aiming for finding what are the root cause, what are the intermediate cause, what are the confounders, what are the consequences, the effects, and so on and so forth. So we have classes of nodes that we want to have in the network, right? So in this one, if I switch to HellixMap, you have the list of the classes. So you see we have the root cause. The main criterion is here. We have the root causes. So we have also aggregators here because, you know, with Hellixia, we can quickly have lots of parents. So Alex had some problem. Olivier yesterday too. He ended up with 57 parents. Obviously, then you have a conditional probability table that is made of 2 power 57 cells. So you cannot manage that. So what we do here, we are divorcing the parents. So we are creating intermediate node automatically for helping to represent, in order to help to represent the relationship with all these parents, right? Then we have the interventions. I can hide the other one. We have intermediate causes too. We have the effects, and we have the confounders, right? Let me up. right? And so when we go to the, so this is my target node. So here you see, I double click, I have the neighborhood, but if I do a right click on the node, I can choose neighborhood here and change the layout algorithm I want to have for this. So I can choose here Helk horizontal, and then it's going to be this representation. Each time I double click, I'm going to have the Helk. Or I can go back here and go back to my vertical one and say, I want a neighborhood, but with a depth of 2, right? So this way, each time I'm double clicking on a node, I have the neighborhood with a depth of 2 that is laid out with the Helk algorithm, right? So, oops. We have also the risk-centric causal network. So this one is also a constraint causal network where we really want to focus on risk, right? So it's like, so I did 2 webinars on that. The last 2 webinars were on this topic. So it's really like a probabilistic bow tie, if you want, right? So we have the target is your main risk, right? And then we are identifying what are the threats, what are the preventive barriers that you can put in place, what are the effects, and what are the mitigating barriers, right? And so this is done automatically with Helixia. And so here, if I do that on GEO, so the same target as before, I'm gonna have here, if I hover my node, I see that this is not what can I do in order to have an effective GEO, but what are the risks that I'm failing to have an effective GEO, right? And so we see that we have 5 risks here, sub-risks. So poorly structured content, insufficient authority signal, unnatural language pattern, and so on and so forth. And then if I double click on the first one, I'm going to see that the threats, the main threat for this one is a lack of AI readable content structure in your website, for example. And what you can do in order to prevent this threat, right? So you can use semantic markup implementation or implement semantic markup. You can use content hierarchy optimization and entity recognition enhancement, right? And these, so they are, so when it's red, this means that this is decreasing the risk, blue increasing the risk, and you have the local effect here. You see this one as an effect of minus 0.6, this one minus 0.65, and this one minus 0.7, right? And then, so you can go from risk to risk. So insufficient authority signals, you can put in place a strategy for authority building. You can work on citation and references and have expert author profiles, right? And then if this risk is true, or you are in trouble, then you can have a reduced AI citation frequency, decrease organic traffic, and so on and so forth. So these are the effects associated with the main risk. And if you double click on this, you're going to have the preventive or the mitigating barriers, right? So if you have this problem, then you can use AI citation monitoring system and AI engine relationship management, right? And I'm not showing that now here, but there is in the new version that will come soon, you can also check to generate this risk-centric network plus utility nodes, right? So that will allow you to have a kind of influence diagram. So then you have utilities that are associated with each barrier. You need, well, for the moment, you still need to put the price manually. We are going to try to see if we can implement that too, but it's quite difficult. And then so you are going to have prices associated with each barrier. You are going to have cost associated with each effect. And then you can use a genetic algorithm optimized for optimizing the strategy So what are the barriers that are worthwhile to put in place in order to reduce the cost? Okay. And to conclude, we can also, instead of just using the implicit knowledge of the LLM, we can also use Elixir for knowledge mining, but from documents, right? So, and I say from document and LLMs, because it's never easy to know when the LLM is just using your document or is also using his implicit knowledge, right? So here, so this is, I don't know if I would have time this afternoon to present my one of my favorite topic about philosophy. So I have another talk, but perhaps it's gonna skip, I don't know. But anyway, so perhaps I can say a few words now. So yeah, perhaps I can do that now. Yeah, I'm gonna do the two talks in the same. Here, what I've done, I have a tool that I have developed for, you know, what I call that multi-chat, but it's like, because usually when I'm using ChatGPT or Claude or any other one, I ask a question in one, and then I check, or I do the same thing in 2 or 3 other tools, and then I compare the solutions, and I put the best one in the other one to critique and so on. So it was kind of tedious. So I have a tool that does that automatically for me. And I have 2 modes. I can do that for really critique. So here is a solution of the first one. You go through that, you analyze it, and you critique it, and you give me a new answer. Or I have also a dialogue mode, a conversational mode. So the second LLM will answer the first one, and so on and so forth. And so what I did is I created a dialogue between 16 philosophers, right? So I say, what is chance? So it's a philosophical question, but it's also linked, obviously, with Bayesian network, because Bayesian networks are really a philosophical tool, because we are trying to find causes, which is obviously a philosophical question, and we are trying to model the world, right? So I asked this question, what is chance? I have 16 philosophers, from Democritus to Nietzsche, right? So those I read. And then each one answers the question or criticize the answer of the previous one, right? And then so I had these 27 pages of answers. So each philosopher is implemented with one LLM. So I have 5 different LLM. I'm using GPT, Anthropic, Claude, Mistral, DeepSeek, and Gemini, right? So they are randomly associated with the philosopher, and then I create this. And then once I have these 27 pages, obviously you can read them, or you can also create this kind of graphs that will analyze them. So this is one of, so the semantic diagram. So you see a question about chance, then movement of atoms. So this is Democritus here. Appearance of change, mechanical necessity, form or ideas. So this is Plato, and so on and so forth. So and at the very end you have the love of faith. So this is, hello friends. You arrived exactly at the correct time. Perfect timing. And so this is my favorite philosopher. We talk about it. We mentioned it yesterday with Schopenhauer. So you see the will here, and so the solution is a negation of will. So you can die, you have to die, but without eating. So this is the only authorized way to die. You cannot kill yourself by using another way, right? So very optimistic philosophy. And so this is a semantic flowchart, and then you can also create a knowledge graph based on the document. So here we are identifying the entities, and then so I'm going to directly switch to the other one. Yeah, can do that very quick. I hope Gabriel does not have anything. Where is it?
While Lionel is looking for the file, should we lower the blinds? Can you see the screens okay, or what's your thinking? I can see it okay. You can see it okay?
Yeah.
Yeah, okay, then I'll leave the blinds up so we don't have to sit in darkness. Okay.
Yeah, so this is a direct transition with with the So yes, so the question is, what is chance? And so as I said, I created, I used 16 philosophers, virtual philosophers, right? So from Democritus to Nietzsche, and lots of German philosophers here. I don't know why. Just two French guys, and some English again. And you have this one, Gita. So I don't have any name for this because this is not. There is not one philosopher here. It's just. Well, I don't know if it's. We can call that philosophy. And so here, so I did that a month ago, where the order was random, right? So, and I have Machiavelli and so on, and by chance it was Machiavelli who started, and then everything has been, biased towards political vision, right? So here now, this one is more like I say, okay, I'm going to start with the oldest one and finish with. So it's really the chronological order here. And as I said, I have two. So as you can see, these images have been generated by using Elixir. Right? So it's quite nice, I think, to have these guys represented like that. And so here I have, as I said, the iterative mode. So this is like each one is answering the question, what is chance, by taking into account the previous answer of the other one. And then I have here another one for the conversational mode, right? So they are answering the first one, Democritus, at the end of the day, the answer is more or less the same one because he is starting, right? But then Plato will answer based on the answer of the other one, right? And then, so here I have the document, and from that I have all these pages that I want to analyze, and I will just here show you the semantic flowchart of this iterative process. So you see, Democritus is with this, the atomic determinism. So I don't know if you can read that. Can you? Or otherwise, we can go there. So here, this is really an illusion of masking ignorance of orthoreal causes. You have all these atoms that are moving, in the void. And then Plato is criticizing that. So he said, no, you have the sensible world that still escapes the grasp. So they agree on the fact that it's ignorance, right? It's an epistemic uncertainty. Then you have Aristotle with the accidental convergence, right? So with the automaton concept here. After that, you have Epicurus with the clinamen, where there is some randomness in the atoms here that can explain, where you can really have chance. So it's like ontological now chance, where that can explain, or at least allows you to have some free will, or you think you can. So, and then you can, thanks to this free will, you can reach ataraxia. Then here, if we go up, we have the Gita. So here it's more like the karma. So what you do will have an impact on that. Then Machiavelli, obviously, again, it's going to be political here. So there is chance, obviously, this is something you don't know, but you have to understand and try to guide the people, right? So the prince, I guess you read this book. Then you have Hobbes. So here it's like you have to have the Leviathan in order to reduce. So there is chance uncertainty, but thanks to this political organization, you can reduce the risk. Descartes and so on. So I will not go into the details. You have the link to, I can give you the link to this network. I think it's quite interesting to see. And obviously, so you have Schopenhauer, as I say, with this, the blind will, and Nietzsche, which is considering, so this is really the amor fati. You have uncertainty, but you have to agree with that, and this is something good, right? And then, oops. So this is a knowledge graph for this 27 pages, right? So if I click on HellixMap again, because you can see that otherwise it's complex. So you have this graph. So this is one of my current research too now. So if you have ideas, they are more than welcome, because it's very nice to have this graph, but sometimes I have graph with thousands of nodes. And so even though you are familiar with graph, when you have thousands of nodes, it's not easy to navigate there and to find a way to grab really the knowledge that is encoded in this knowledge, in this graph. So for example, here you see that there is one node that have lots of connections. So what I did, we have this search function that allows you to search for nodes, obviously, or for within the node name or the comments. You can also search for in the links, because the links have comments also associated with them. And here you see you have the names that are displayed by default, and you have also the neighborhood. So I think it's a very important characteristic for each node. So here I know that chance has 41 neighbors, right? And at the very end, you have lots of nodes that are alone, or not alone, but just one neighbor, right? So they are less important. So you want to, usually I'm starting when I'm uploading a big document about retirement or about anything like that. You have 300 pages, you don't know what to do, so you create this kind of graph, and then you want to see what are the barycenter, what are really the important concepts there. And so I'm using this. So before I was just clicking on the first one. So if you click on it, you're going to focus on it. And then obviously, again, I can double click on it just to see the neighborhood. But this one, let me change it. Perhaps it can be better. This way, horizontal. This way it's better. So you see that it's changed, and it's obviously the barycenter of my network, because it was the question, right? So they all answer this question. So we have, you see the chains here, you have the word here that contains chains, you have the enlightened individuals, you have natural forces, you have the powerlessness, so you have all these things that have an impact, or not an impact, but are connected with chance, so karma and so on. You have causality, so we can double click on causality to see what is behind that. And then you see your necessary connection, a priori principle, the atoms, the habits. So this is coming from Hobbes or Hume, I guess. Causal chain, you have the phenomenal order, Democratis here, and then you can go back to chance here, and so on and so forth. So you have this way to navigate. So I've started here with chance, which has the strongest or the highest number of connection, and then we have also a way now to directly. So if I do Control U, I am going directly to the node that has the highest number of neighbors. And then if I do D, like so up and down, I'm going to go to the second one. So the second node that has the most neighbors, right? And then I go down. Now I have necessity. If I continue, this is contingency. And then I have ignorance, then reason, laws. So you see, so this is a way to navigate in the graph. It's not perfect, because you can be lost too, but at least you have a path. I still need to find a better way to navigate in this graph, but if you have ideas, feel free. And then, so if I double click here, I come back. Then the iterative one, so this is a causal semantic diagram. So the other one was a knowledge graph, right? So we have the same thing, chance. That is, let me go back here with the healthcare, horizontal. So you have the free will, you have the probability. So if we double click on probability, you see there was no icon associated with probability, so it's just a root node here, if you will. That probability models chance, so we are here for that. What can be interesting here, human ignorance, finite intellect, reason and experience reduces human ignorance, reason reduces, and then this is also a cause of superstition that result from chance. And so this is the epistemic chance when you have ignorance, right? And for reason, we have the prior knowledge, so this is coming from Kant, and so on and so forth, right? So different ways to analyze this document. And then we have the conversational one. So here again, Democritus started, and it's a discussion between these guys. And at the end of the day, the conclusion is for Nietzsche, right? And so we have, so I will, Stefan, you will pronounce that for me. Übermensch? Ah, you can see.
Übermensch.
Übermensch, yeah. Where is my, oh. Übermensch, which means?
Well, like superhuman.
Ah, okay. Right? So this is the workflow here for this discussion between these guys. And I think I have a last one. So this is the flowchart I just showed you previously. And the knowledge graph for this one, which contains how many nodes this one? Yes, you have 253 nodes, so you see it's not easy. And here, the most important one is Nietzsche, right? So if I go there, I'm gonna have the with my friend here, Schopenhauer with the blind will, temporal illusion, asceticism. So there is one that values asceticism and the other one that criticizes it, right? And so here we have Maya. So this is coming from Gita, and so on. So obviously it's not, we cannot analyze all these things during this presentation, but yeah, I think it's interesting. And the causal semantic diagram, right? So now we have the causal relationship between these entities, right? So perhaps just a last HellixMap on that, just to see what is very center here. It's freedom. So this is the node again that has the most neighbors. So we have amor fati from Nietzsche. We have the knowledge here that allows you to transform freedom. And then if we go down, we have morality. Oula, how do you say that?
Sittlichkeit.
Oh, this is nice. Right? This is Hegel, I guess. No? Who's that? Where was that? Not find it. Right? Anyway, so here you have, here it is. Hegel. Yeah. All right, so you have this this way to analyze your documents, and so you can create an account if you don't have already on the HellixMap. You will be able to publish your network from BayesiaLab, and you can also use directly. There is an access to the API, so you can use it also for creating a graph directly with HellixMap, right? And that's it.